friends, so today we will see what is file system management in operating system. So first we'll understand what is file system. So file system is basically a data structure and method used by operating system to organize and manage data on any storage devices like hard disk and SSD. Okay, so file system is basically a data structure and method. So we'll take example of Unix based operating system. We'll see how our files are organized into this kind of operating system. Okay, so first point is file system creation. So during the initial formatting of the file system, operating system will use 1% of disk space will be used to create inode table. Okay, so this inode table will be created by the operating system by using 1% of disk space, and this inode table will contain some fixed number of inodes. So we will see how these inodes will be used in file creation. Okay, and this is our storage devices where our actual file data will be stored. Okay, so we'll see mapping of this both. Now second point is file creation and deletion. So suppose user creates a file doc.txt. Okay, and user wants to save this file. User will click on, the moment user will click on save as, so operating system will receive a request and user wants to save this file. So what operating system will do? Operating system will find available inode from this inode table. So suppose this inode is free. Okay, so this inode will contain unique inode number. Suppose 123 is the unique identifier of this inode. Okay, so what operating system will do? It will assign one inode for this doc.txt. So what will be the directory entry for this doc.txt? So suppose this file is the file location is home. This file is stored into home user document and doc.txt. Okay, so directory entry will be file name doc.txt, inode number is 123. Okay, so one inode will be assigned to this doc.txt by the operating system. Now we'll see how and our data will be stored into the storage device. Now in next point we'll see how inode will be mapped to our storage devices. Okay, so similarly at the time of deletion, this inode will be deleted. For this doc.txt, this directory entry will be deleted, and all the pointer pointing to these storage devices will also be deleted. Okay, now third point is metadata storage. So what this inode will contain? So this inode will contain all the metadata information about this doc.txt. So what is the metadata information? File type, file size, ownership, permission, timestamp, and address of disk block. Disk block address. So all this information about the file will be stored into our inode table. Inode table will consist number of inodes. So this inode is assigned for doc.txt. So this will not contain file name. This will only contain inode number and all this information. So it will also contain disk block address. Okay. So this is our storage devices. Our actual data will be stored into these blocks, and address of this block will be stored into our inode. So this is our pointer. So this is direct pointer. So suppose our file size is small, so we'll have only one direct pointer. So suppose our file size is large. Suppose 456 is another file which is larger. So we'll have this indirect block also in middle. And suppose this is some large file, so this will contain this will contain two blocks from the disk space. Okay, so this is how files are stored into Unix based operating system. Okay, so inodes will be created and this inode will be mapped to the storage devices. Okay, so file access and modification. File access and modification. Okay, so suppose user wants to access this doc.txt. So what operating system will do? Operating system will search from the directory entry directory entry. So this is the directory entry. So it will search doc.txt. Then it will find inode number of doc.txt. Now 123 is the inode number of doc.txt. Now operating system will point to the this inode from the inode table. So this inode table will contain all the information about the file, all the metadata information. So this has a pointer to the disk block. Now operating system will find out address of the disk block for the file and it will point to the disk block and it will open the file for the user. Okay. Now fifth. Now user will open the file and they can access the file and they can modify also. Okay. And access control. So when user wants to access the file, so we have permission information in our metadata storage. Okay. So so from this operating system will understand whether this user is authorized user or not. Based on this, the user will open the file for the user. So it will prevent unauthorized access. Now sixth point is data integrity and recovery. Okay, so file system will implement some mechanism to ensure data is accurate and accuracy of data. It will ensure, and in case of any loss of data, they will create some backup mechanism also. Okay, so they also provide backup methods in case of loss of data. Okay, so this is the file system management in operating system. Okay, so each operating system has their own method and data structure. So in this video we have discussed what data structure is being used into this Unix based operating system. Okay, so in short I'll explain each point once again. So what is file system? This is basically a data structure and method used by operating system to organize and manage data. So during first formatting of the system, in Unix based operating system, inode table will be created, and during the so file creation, suppose user wants to save this dog.txt, so operating system will assign one unique inode number for this new file. In case of deletion, it will delete inode and it will delete all the pointers also pointing to disk block. Metadata storage, each inode will contain all this information about the file. And file access and modification, so user can use this, user will first search from directory entry and it will find the inode number. Operating system will find the inode number and it will point to the corresponding inode from the inode table, and inode will contain the directory and direct pointer to the disk block, and now user can access and modify the file. Okay, access control, so based on this permission information, it operating system will prevent unauthorized access, and it will also provide some mechanism for data integrity and recovery. So accuracy of data, it will also provide mechanism for accuracy of data. It will ensure accuracy of data and provide some mechanism for backup also. Okay, so this was the file system management in operating system. So in next video we will see security management in operating system. Okay, thank you.